In this, the final module of our course, we are going to discuss the last major component of computational thinking, abstraction. Abstraction is identifying specific features to make one solution work for multiple problems. For example, a city map is an abstraction. It doesn't contain all the details of the streets, like the cracks in the sidewalk or where flowers are planted, but it does contain the details that you need to find your way around the city. The Mad Lib activity you completed in Module 7 is another example of abstraction. The story's author had to generalize the words pulled out of the story by abstracting them down to their part of speech like verb or noun. The abstracted story could now work for multiple solutions or versions of the original. Abstract art has pulled out the details but is still recognizable as general objects. For example, this picture can be recognized as a face, but we don't know the detail of whose face it is. It could be my face, it could be your face. We don't know because the face can be generalized to represent many different faces. A math example of abstraction is formulas. The Pythagorean theorem provides a generalized solution that works for any right triangle. You can calculate the length of the hypotenuse by knowing the length of the other two sides. The formula a squared plus b squared equals c squared has abstracted out the exact lengths of the sides of the triangle, but kept the important information of which numbers to square and which numbers to add. You perform abstractions all the time. I can ask you to draw a square and you would be able to do it. That's an abstraction. I don't have to tell you the details of how to draw a square. You stored that information in your brain somewhere already. Similarly, computer scientists use abstraction to create generalized solutions that will work for a variety of problems. In a program, we can write a small chunk of code that draws a square, then give it a name like draw square. Then we can just tell the computer, draw square, and it can access the instructions to draw a square without the need to be told again and again and again how to do it. Abstraction is the key concept in computational thinking, and possibly the most difficult one to get used to. So if you're still unsure about what abstraction means, hang in there. The next few activities will help make things a bit more clear.